Hello, today we are doing Chapter 6, Section 1. Our essential question is, how can you write general rules involving properties of exponents? So, first of all, let's talk about some of the properties. The first one is the zero exponent. And this one is really easy, but it's an easy one to forget as well. If you have 0 as your exponent, your answer is always going to be 1. Anything to the 0 power is 1, except for 0. 0 to the 0 is undefined. So 4 to the 0 is 1, x to the 0 is 1, a bazillion to the 0 is 1. The next one is the negative exponents. We don't like negative exponents. So what you can do is you can move locations. If they're in the denominator, you can move it to the numerator, and the exponent becomes positive. If it's in the numerator, you move it to the denominator, and it becomes positive. It just changes locations. So let's go ahead and do a couple examples. So on that first one, 6 to the 0, anything to the 0 power is 1. On the second one, we have negative 2 to the negative 4. And again, we don't like that negative exponent. A lot of times I'll think of that all over 1, and it's going to go down into the basement. So we're going to take that, and we're going to move it down. So I'm going to have 1 over negative 2 to the 4th, which, remember, negative 2 to the 4th would be negative 2 times negative 2 times negative 2 times negative 2, which is going to be 16. So 1 over 16. So let's do one where we kind of combine a few things. Here we have 4x to the 0 over y to the negative 3. First thing we're dealing with is that negative exponent, because we really don't like those negative exponents. So what I'm going to do is I'm going to take that y to the negative 3, and it's going to change locations. We're moving it upstairs. Because it's already down in the basement, it's going upstairs, and when it moves, it changes signs. Then the next thing we're going to deal with is that x to the 0. Anything to the 0 power is 1. Now that 4 is a different factor, so it doesn't become 1. So that's going to be your final answer right there, 4y cubed. All right, so that first one, that's going to be 1, because anything to the 0 power is 1. That becomes 1 over 27, because you'd have 1 over 3 cubed. Our next one is going to be negative 4, because that negative sign is not being raised to the 0 power, so you're going to have 5 to the 0, which is 1. And then you're going to take this, and you're moving it up top. That's going to be times 2 squared, and that's where that negative 4 comes from. Our last one, why don't you take a second, hit pause, try that on your own. It's going to be 1 over 9x to the 5th. We are going to take that 3 squared, and it's going to be moved down to the denominator. When it changes location, it becomes positive. X to the 5th goes down to the denominator. You need to still have a placeholder up in the numerator, so that's where that 1 comes from. And y to the 0 is 1. 3 squared gives me 9, so 9x to the 5th. All right, let's talk about when we are multiplying and dividing. You probably want to hit pause and copy these down, but what it really means in a nutshell is if you are multiplying and you have the same base, add your exponents. If you are dividing and you have the same base, subtract your exponents. A power of a power is you got a power on the outside and a power on the inside. if you have a power of a power, you are going to multiply your exponents. That's going to be something that you will want to have memorized. So here, you're going to have 3, add your exponents to the 8th, and then I'd probably use a calculator or leave it 3 to the 8ths. If I were grading something, 3 to the 8 would have been fine. On B, our base is -4. Subtract your exponents. And again, we don't like negative exponents, so that needs to go down to the denominator. A lot of times what I'll do is I'll look and see who's bigger and kind of think of it as a contest. 7 is bigger, so I would have just subtracted the 2 right there. That look more like a minus sign. And then I would have gone from that first step to the second step automatically. And on our last one, we have a power of a power on the inside of the parenthesis, 1 on the outside. You multiply those exponents, and then we have a negative exponent, so it needs to move locations. All right, why don't you hit pause? Try these 6 problems on your own. All right, power of a product property. Again, I would probably hit pause, write these down, watch the examples, come back and revisit them. But what that really means is if you've got a couple things going on inside these parentheses and you have an exponent on the outside, you're going to take that exponent and apply it to everything on the inside. Same thing, the quotient property is really the same thing. If you have an exponent on the outside, you're going to apply it to everything on the inside. So let's do an example. So that 2 on the outside is going to be applied to the -1.5 and to the y. So then you're going to take -1.5, square it, and the y squared. For example B, that exponent of 3 is going to be applied to the a and to the -10. Simplify, and you get -a³ over 1,000. For C, that 4 on the outside is going to be applied to the 3, the d, and the 2. Use your calculator, simplify it, and you get 81 d to the 4th. And on D, we have a negative exponent. That -5 is going to be applied to the 2, the x, and the 3. Looks like they dealt with the negative exponent first, which is 100% fine. So you're going to have 3 to the 5th over 2 to the 5th, x to the 5th. Simplify that out to 43 over 32, x to the 5th. You want to keep that as a fraction. Don't use your calculator and divide those 2 numbers. We want to keep it exact. All right, why don't you hit pause, try these 4 on your own, and check and see how you did. That -3 is applied to the 10 and the y. The 5 is applied to the -4 and the n. And remember, a negative number does not mean the same thing as a negative exponent. The 5 is applied to the 1, the 2, and here we have k squared, so that's really a power of a power. Multiply your exponents. That's where the k to the 10th comes from. That -2 is applied to the 6, the c, and the 7, and then everything needs to be flipped. All right, let's do a word problem. Which expression shown represents the volume of a cylinder where r is the radius and h is the height? So there's the formula for volume of a cylinder. The radius is h over 2. That's kind of given to you right there. So take that 2 and apply it, and you get h squared over 2 squared. H squared times h gives me h to the third. So it is pi h cubed over 4. That 4 is really the same thing as 2 squared. So if you wanted to, you could have had that as a negative exponent. I don't think I would have done that, though. So that one works. That one works. You can go through and see which ones work. So there was more than one correct answer. All right, a jellyfish emits 1.25 times 10 to the 8th particles of light. That's what we call scientific notation. Probably seen it in some of your science classes. In 6.25 times 10 to the negative 4th seconds. How many photons does the jellyfish emit each second? And you want to write your answer in scientific notation and in standard form. Scientific notation means that first number has to be greater than 1 and less than 10. So we're going to find that rate. So we're finding photons per second. That would be the same as 1.25 divided by 6.25, 10 to the 8th divided by 10 to the negative 4th. And again, this is not going to be in standard because that is less than 1. It has to be greater than 1, less than 10. So we're going to borrow a 10 over here, and it becomes 2. That means that there are going to be 11 zeros, which when you see it that way, that's a lot of light, a lot of photons per second. All right, I'm going to stop there. Hope you enjoyed.